So thank you very much for inviting me today to talk about a little bit about the current seafloor geodetic pool and potential for more seafloor instrumentation and what we have ideas for. And I'd like to hear what the community has ideas for seafloor instrumentation. So this really comes from a set of proposals that have been submitted by primarily this team that we're kind of call the development team. That includes everybody listed here. Dave Chadwell is really a leader of this. He is now retired, so the rest of this work is really being taken on from the rest of the team. I don't want to go too much in details of the proposals, but we first put in this very large proposal for a national geophysical observatory as part of a frontier capability for NGEO. This was not funded, but there was a lot of interest from this. And so in 2019, we submitted another proposal for mid-scale research infrastructure. That proposal was officially not funded, but NSF did pull together about $5.5 million to help pay for and develop this nascent seafloor geodetic pool that includes GNSSA, bottom pressure recorders, and wave gliders, as well as some of the initial commissioning of this work. It does not yet support anything that we would call a facility, no operations and maintenance or long-term deployment capabilities for, let's say, individual PIs. So the pool itself is funded 2 scripts. The scripts owns the instruments. There's enough instrumentation for 17 unique GNSS seafloor pressure sites that are capable for the order of centimeter a year level horizontal measurement and so sort of centimeter a month level vertical measurements over the shorter term. We have 3 different wave gliders that are available for data collection. As of the end of 2021, the instruments are now ready for deployments. But as we said, we just have money at this point for a pool, so there are no funds for deployment, operations, or maintenance or training. These sites themselves, we say officially there's 16 sites, but technically it's 17. There's just one spare of these. It includes 48 transponders with 10-year battery lives. On every 3rd of these, there is an absolute pressure gauge as part of the transponder package, as well as we're including 48 reusable benchmarks. Benchmarks that we can use to, if we need to, take off instruments and redeploy them onto the same sites. The nominal spacing for any sort of site deployment between transponders is about 1.5 times the depth of the water column. The equipment that we have here is currently rated to 3,000 meter water depth. This is, I wasn't sure whether or not I should include it, but this kind of ties into other things we were talking about today. It's a very complicated, very messy slide, but it just shows sort of the range of geophysical things we want to observe and the different types of tools that we have for observations. And so many of you have looked at and are interested in a lot of this. With this instrument pool, we include on the horizontal side the capabilities for annual or continuous GNSSA, so that includes secular coupling tectonic motions, as well as magmatic and some slow slip processes. On the vertical side, with our pressure sensors, we are capable, since we do not have AZA or A0A corrections, we are really only capable for sort of shorter term observations where we can capture earthquake rupture, where we can capture probably most of slow slip activity and many magmatic processes, but some are longer lived slow slip activity, longer lived magmatic processes are outside the scope of these. And even with pressure sensors that are corrected, we're probably still just now hitting the edge of where we may be able to get sort of this secular long-term behavior. So what we sometimes call the interseismic behavior.
1 minute.
Ooh, okay. All right. So what we're doing right now, we have a community experiment planned, and you may have gotten to save the dates. We are planning now to have a short workshop over 3 days in early May to use likely 2/3 of the pool for deployment on a convergent margin or multiple, including Cascadia and or Alaska. With deployment planned in 2023, we have to move very quickly. So some of the details will be hashed out in this workshop. So if you haven't received the call yet, I sent it out to the Seafloor Geodesy listserv. Let me know and I'll send it, make certain that you're either added to the listserv or just resend it to you. The last thing I think that's really important for this group is when we talked at our community workshop, as part of the post-survey presentations, we asked them to give a ranked order of the instruments that are not currently in the pool that they'd like to see in the facility. And by and far, the plot on the right, that the graph doesn't really show the full thing. It says calibrated absolute pressure, but because it's a ranked order, it's better to actually look at these numbers. 16 out of the 29 respondents argued that calibrated absolute pressure was the top priority. So this is really the additional tool that we need. And so I'll just leave this up since I'm running out of time. This is really restating the things I've said in just the last couple of minutes.